Have you ever picked up a pair of channel lock pliers and thought to yourself, man, these are really heavy. I wish there was a lighter tool to accomplish the same task. Well, now there is. Welcome back to the Lumberjack Engineering Workbench. And today we're going to be taking a look at these 3D printed channel lock pliers. And we're going to actually investigate and do some testing to see if these are even worth the plastic that they're printed out of, or if they'll just deform and snap the first time we try to use them. So what you're going to see in just a second is a time lapse of these guys being printed. And then after that, you'll come back and we'll actually give these a test in a real world situation. See you guys in just a minute. Alright, after we went ahead and printed those out, I went ahead and assembled it all together. Real simple, just these two main parts and the snap ring in the middle to hold it together. Now, to test these, we know that we're not going to be able to get anywhere near the torque that we could with an actual set of channel locks. Even as craptacularly Chinese as these may be, they're still going to be near infinitely stronger than these plastic ones. However, what I'm curious is, will it allow me to tighten a bolt, or a nut in this case, tighter than I would be able to by hand? So what I'm going to do is grab on to that nut with the metal channel locks and go ahead and crank down on that one as tight as I can by hand. Now, so if we can tell if it moved or not, I'm going to go ahead and put a Sharpie mark indicating, if I don't suck at this, where these two line up. Now we're going to grip the rear nut with this metal channel locks again and grab the front one with these plastic ones. You'll notice when I do this that I am grabbing pretty high up near the jaws of the pliers. Ideally, for max torque, I'd want to be grabbing down here. However, being plastic, it's essentially Spring City, and I'm afraid it'll just snap before I can even try anything. So, I'm going to go ahead and grab... Oh, was that it? Nope. So what happened there, and what I've kind of noticed it doing and playing around with it a little bit, is that this, gosh, I don't know what to call it, follower or retainer, the part that actually locks in and has to bear the force, likes to pop out of this serrated side. Can we grip it like that? Nope. So I'm going to try that again and see if we can do a little bit better. Grab up. This time I'm going to try to keep my finger on the back side of it to make sure these two halves actually do stay together pretty well. And twisting. Okay. Let's take a look at this. Might have gotten it a hair tighter than I could by hand. That being said, they were pretty tight already, so I wouldn't expect a whole lot of movement. I guess the real test is to see if I can get these apart by hand. Which the answer to that is absolutely not. So that's kind of cool. These were actually able to tighten farther than I was able to by hand. We try to get this off again. There we go. So, it's actually kind of nifty. It's really surprising, even, because I honestly expected these to not work at all. Obviously, the strength of this part, is going to be determined a lot by the infill density. Some people think that a 3D printed part is entirely solid, and while that's a possibility, you can do that. 99% of the time, you're actually going to print things mostly hollow. I'm going to pop up a comparison picture over here and over here of what something like 10% infill looks like compared to 25%. And what that means is that the 10% side here on the left, 10% of the space inside of the part is actual material, the other 90% is just air. While over on the right, with a 25% infill, we've got 25% material, 75% air. So as you can imagine, the strength of parts can vary greatly depending on the infill. Now, it's not exactly a linear relationship. If you had 30% infill, you can't necessarily expect 3 times as much strength as if you had 10% infill. But generally, higher infill does mean higher strength. I believe I printed these at somewhere around 25%, which is what I often use for what I would consider structural parts. If there's something that's really load bearing, I will go higher. But if I were to design these, I would definitely make these two parts thicker, for sure. There's a lot of flex in there, which is what contributed earlier on when it popped apart. And we can actually probably go ahead and recreate that, especially if I grab down here. Oh, maybe not. Oh, yep, there we go. And like I said earlier, what that is this follower popping out of the serrations over here. So I would go ahead and make these parts thicker, which would make them stiffer. And while I was at it, I would make these slots wider and this follower wider as well, to give a little bit more stiffness to that part so it won't pop apart so easily. Overall though, I am actually pretty impressed with these. I thought they were pretty cool, and worked honestly better than I expected. Oh, apologize for the rather rude jump cut, but I was about to end the video without telling you a use for these pliers that's actually valid. Say, for example, you wanted to grab onto a material without marring it. In this case, it's just a small little finger screwdriver, Craftsman, I think. Yep. But in reality, this could be a piece of glass or anything else that you want to be able to hold rather firmly, but without leaving jaw marks in it from these serrations. Obviously, if I were to grip hard with these, I could actually deform this aluminum knurling a little bit, flatten some of those points, and if, heaven forbid, if I were to slip while turning it, you would probably take off all the anodizing. Not all of it, but you know, you would definitely mar it up for sure. But with something like this, you're going to be able to hold on to that. I'll go a little bit taller. There we go. Keeping a decently firm grip while making sure at the same time that you're not going to mar up your surface. Because although PLA is a rather rigid plastic, it's still definitely nowhere near hardened steel. Not even close. So that's actually a rather valid use for a pair of pliers like this. Don't know if I'll ever use them like that, but if I do, I'll probably post about it on Instagram now, because that would actually be kind of cool. Anyways, what I was about to say before I so rudely interrupted myself was that if you like this video, please go ahead and hit the like button over here. Make sure you're subscribed here on YouTube, and then if you really like me, go follow me over on Instagram, where you can find me under Lumberjack Engineering as well. So with that, guys, have a great day.